Alrighty, we are reviewing for our parallel, perpendicular, and transversal lines test. We're just going to dive right into some whiteboard problems that I've prepared that should cover all of the concepts that you will be tested over tomorrow. Alright, so in this problem, you've seen this before on a homework. Given line W is parallel line X, so I'm going to go ahead and add arrows to my picture. Line E is not parallel to line D. So I'm going to remind myself over here, whoa, those two are not parallel. Name the following angles. Categorize them as congruent, supplementary, or neither. So our first one, angles 1 and 3. Now those are corresponding angles, for sure. You can't argue that. They are definitely corresponding angles. But to use the corresponding angle theorem, or the CAT, you would have to have parallel lines. If E is parallel to D, then corresponding angles are congruent. And if you take a look here, oh no, E is not parallel to D, so these normally would be congruent, but we're going to say neither because we don't have parallel lines. So if you don't have parallel lines, you can't use our parallel line theorems, the corresponding angle theorem, the same side exterior angle theorem, all of those. Angles 1 and 6. Angles 1 and 6 are same side interior angles. Let's take a look at what lines we need to create those. So to create angles 1 and 6, we need W, we need X, and we need D as our transversal. Since we know W is parallel to X, we can use the theorems we learned. So the same side interior angle theorem says if angles 1 and 6 are same, so if W is parallel to X, then angles 1 and 6 are supplementary. Same side, supplementary, same side, supplementary. If we have parallel lines, which we do. So 1 and 6 are supplementary. 1 and 5. Vocab word, that's how we always start these things. 1 and 5, vocab word. Alternate interior angles. The question is, can we use a theorem or can we not use a theorem? And to find out, you take a look and see, oh, yeah, we're using W and X again. W is parallel to X, so we can use the theorem. Alternate interior angles are congruent if our lines are parallel. Last but not least, 6 and 5. We always start with the vocab word. Those angles are from the angle unit, not even from this unit. They're called a linear pair. The theorem says if two angles form a linear pair, then they are supplementary. It doesn't rely on anything else. It doesn't need parallel lines. It doesn't even need 3 different lines. If two angles form a linear pair, then they are supplementary. No matter what, no conditions needed. Alright, let's try this next one. Write the equation of the line. So my students sometimes get confused with write the equation versus what is the slope of the line. So the slope of this line is 0, but that's not what it's asking. It wants the equation of the line. So I always say, okay, which axis, oops, I keep writing Z here. I keep wanting to be 3-dimensional, guys, in calculus. Okay, so this line is intersecting the y-axis, so it's going to be a y equals. It's going to be y equals a constant, because our slope is 0. If you can see, this makes a Z for 0. Y equals 0x plus, what's our y-intercept? 5. But we would not want to write our equation like that on the test, so we would just say y equals 5, because 0 times x is 0, and we don't need to write the 0 down. So y equals 5. This line is parallel to the x-axis, but it's a y equals line because it intersects the y-axis. Write an equation parallel to the given line. So we learned 2 main things. We relearned it because you already learned them. Parallel lines have equal slopes. Perpendicular lines have opposite reciprocal. Equal slopes. So when you don't know what to do on the test, at least find the slope, because that's going to kind of spark your attention and you'll hopefully realize what to do next. So we're going to at least find the slope because we don't really know how to start. So we count our rise and we count our run. We're rising 6 and running 2. We always reduce this. Our slope is 3. And the grammar is bad on this problem. I'm sorry about that. I meant to put it in there. Right? An equation. So that means any equation. We get to pick the equation. What we need to understand is that if we want to be parallel, the y-intercept does not matter, as long as you don't name the y-intercept that's already in the picture. So y equals 3x plus, it does not matter what you pick. So you can pick any number at all there. I could turn this into 18. Any line will be parallel to this line if it has a slope of 3, and that's what we really cared about there. What is the slope of a line perpendicular to x plus 7y equals 3? I taught my students a quick trick. If the equation's in standard form, the slope is always negative a over b, where a is the coefficient of x and b is the coefficient of y. You might have learned that in Algebra 1. In this example, there's an understood 1 there, so the slope is negative 1 over 7. Negative a over b. To be perpendicular to that, you just do the opposite reciprocal. So opposite reciprocal of negative 1/7, well, opposite means change the sign. Reciprocal means flip the fraction. I would not put that in my answer blank. I would clean that up a little bit. Positivity is understood, so you don't have to write the positive, and the over 1 is understood. So the answer to this problem is 7. Now, if you don't like that trick and you don't like the negative a over b thing, of course, you can just solve for y. So you can subtract x from both sides, and then you can get y alone. Divide by 7, divide by 7, divide by 7. So y equals, take a look at what's going on here, negative 1/7 x plus we don't really care. Remember, the y-intercept does not affect your parallel and your perpendicular. Okay? What is the slope of a line parallel to 5x plus 2y equals 5? I'm going to use my little trick, but you're welcome to solve for y. So the slope of this line right here is negative a over b. The cool part is, you're done. You don't do anything. You don't change it to positive. You don't reduce it because it can't be reduced. You don't do anything if you want to be parallel. Parallel lines have equal, exact, copy, paste slopes. So what is the answer? Negative 5/2. I don't do anything to the slope of that line I was given. What is the slope of a line perpendicular to 2x minus 3y equals 7? Negative a over b. A lot of my students got confused by this today in class because the slope of the line they gave us is not negative 2/3. Those negatives cancel. The slope of the line given to us is 2/3, and then when we find the opposite reciprocal, the answer is negative 3/2. So a lot of my students were getting the negative and positive mixed up. So be careful. Don't do opposite reciprocal until you've cleaned up your slope. So like, let's say you got a slope of, you did negative a over b, and you got a slope of negative 6 over negative 3. Don't do the opposite reciprocal yet. First clean this up. Oh, that's actually 2. Whole number positive 2. Now I can do the opposite reciprocal and get negative 1/2. That was the symbol for perpendicular, sorry. So anyways, clean up and simplify your slope before you do opposite reciprocal. All right, I just threw lots of different slopes on the board. That little m every time means the slope of those segments. It's not the length of the segments, it's the slope. I just used that notation. Let's find some lines that are parallel. So if these are all their slopes, and I want to find lines that are parallel, what am I looking for? Oh, the exact same slope, matching, identical twins. So the slope of RS is 7/5. The slope of ON is 7/5. No, you cannot box PQ because it's negative 7/5, and that changes the slope entirely. All right, let's find some that are perpendicular. All right, so if I take my original one that I started with, the slope of RS is 7/5. What would be perpendicular? Opposite reciprocal. So RS would be perpendicular to ZY. Let's see, these two, negative 7/5 and 5/7, that's another example of perpendicular. There's a couple more examples, but like these two. But we did the job. We figured out how to approach a problem like that. Don't forget when you're trying to solve problems, don't forget where these angle pairs go, as long as you're remembering that for those 5 above the squiggly line, for those 5 to be true, the hypothesis is if parallel lines, then all of the above. Our lines have to be parallel for alternate interior to be congruent, for same side exterior to be supplementary. These down here, vertical angles are congruent no matter what. And angles that form a linear pair are supplementary no matter what. So they don't depend on lines being parallel. So with that knowledge right there, we can solve a problem like this. You won't always know the answer to the missing angle right away. Find the value of z. You can't find the value of z right now. First, you have to find the value of x. So I'm going to use, well, I'm going to do this first, and then we'll talk about something. On the test, don't write a single equation down unless you know why. Why did I set those equal? You have to have a reason, or else they might not be equal at all if you can't think of a reason. Okay? So, yes, these are equal. Why are they equal? Because they are vertical angles. And the vertical angle theorem says they're always equal. They're measures at least. Okay, I'm going to add 81 to both sides. 8x equals 5x plus 81. Subtract 5x. 3x equals 81. X is 27. It didn't want us to find x, it wanted us to find z. So now to find z, we're going to plug 27 in. You can plug it into either angle. You're going to get the same thing either way because they are the same angle. So if you plug it in here, you'll get 135 degrees. Now we have to look at our parallel lines and our transversal. We want them to be parallel. So if, let's see, what's the vocab word? If same side interior angles are supplementary, then M is paralleled in. So we just need to force these to be supplementary. How do we do that? To find z, we do 180 minus 135. So our final answer is the value of z that we need is z equals 45 degrees. So we use vertical angles, then we use same side interior angle theorem, or the converse of it. These are the problems that really trip students up the most. They get really confused when it's not parallel lines in a transversal, but instead it's a shape. So every time you get a problem like this, I want you to get a highlighter out, I want you to get a marker out, I want you to get a patty paper out. Whatever you need, you're allowed to use all of those on the test. Whatever you need to do, I want you to either highlight, trace, or extend the lines that are parallel or that need to be parallel. Highlight, trace, or extend those lines. That means make them longer. Now, to solve for x, we can use transversal C or transversal D. Only one of those is going to solve for x. The other one's not involved. Hopefully you can tell right away. The transversal we need to focus on is C. Because we're focusing on that transversal and all we need is A parallel to B, this was actually extra information. It was there to trick you. You don't need it to solve this exact problem. So you won't always use every angle you're given. That 125 is a distractor. So the angles left over have a vocab word. They are same side interior angles. And if same side interior angles are supplementary, then A is parallel to B. So what do? We surely do not set these equal. We add them to equal 180. I will cut to the chase. X is going to equal 44. I just wanted you to know how to set it up, though. I know you can solve for X by now. Find X so that A is parallel to B. Similar problem, way easier than the one we just did, actually. You identify the vocab word. Same side, exterior, angles. And you're like, okay, if I want A to be parallel to B, these angles better do what the theorem says. And the theorem says same side, supplementary. Same side, supplementary. So 4x plus 10 plus 110 equal 180. Now, some people stare at this problem and right away they can see, oh my goodness, it's 10. I already know this angle is 70. And they do 4x plus 10 equals 70. Don't worry, that's the same thing as adding them to equal 180. If you can see what the angle is by doing mental math, then go for it. Your numbers will be smaller to work with when you solve. On this one, x equals 25, I believe. Just kidding, 15. X is 15. So either doing this one or setting it equal to 70, x equals 15. You need to remember what these markings mean. We've got parallel lines. That's what this means. We've got some congruent angles. They're giving that to us. We're not using a theorem. We're not assuming. But they are literally telling us these angles are both 41 degrees. And we just need to solve for x. So we can use our good old corresponding angle theorem, CAT. So this angle right here, that's 41 degrees, and this angle right here are corresponding angles. Since we have parallel lines, we are allowed to set them equal. So x is 10. 4x plus 1 equals 41. X is 10. True or false? If a line is parallel to the x-axis, then its slope is 0. When you encounter problems like this tomorrow, I want you to sketch a picture, sketch a picture, sketch a picture. So draw your little xy axis. Okay, parallel to the x-axis. So get out a different color or just get your pencil and make sure you can tell the difference. So the green line is the line in question. The green line has a slope of 0, true or false. And in this case, it's true. If this had said the y-axis, it would obviously be false. But the problem as presented was true. When you get confused between 0 and undefined, 0 and undefined, just sketch a picture. Last problem. So, you will be given some segments on your test and expected to answer questions about the perpendicular bisector of those segments. Let's handle these words separately. Perpendicular and bisector. Perpendicular means it crosses at 90 degrees. It means it has opposite reciprocal slope. So we're going to find the slope and then we're going to do the opposite reciprocal. That's how we're going to handle the perpendicular part. How do you find slope? You count the rise and the run. You can always do the slope formula, or you could count. So it looks like I'm rising 5 and running 10. Rising 5 and running 10. So the slope of the line they gave us is 1/2. The slope, of the perpendicular bisector would be the opposite reciprocal of 1/2. So it would be -2. The slope is -2. Even though it didn't ask us, let's draw the perpendicular bisector. Let's do the full thing. So the bisect part means it better pass through the midpoint. How do you find the midpoint of a segment? Well, you don't go the full rise and the full run. You go half the rise and half the run. And unfortunately, this one is not going to be a whole number. Half of 5 is 1, 2 1/2. And then we head over 5. 1, 2, 3, 4. So there we go, right there. Okay, so that's my point. And on the test, it probably won't be a decimal like this, but if I wanted to draw the perpendicular bisector, I would start at that point, and I would count down 2, right 1, down 2, right 1. So down 2, right 1. Down 2, right 1. So on and so forth. And then you could use a straight edge. It might not be perfect, but that should be about the perpendicular bisector. So opposite reciprocal slope, and then find the midpoint.